Well, we got the PS4, the Heathkit PS4, all the components changed. I had to change every resistor in this. There was not, well, there were a couple that were within spec, but they were right on the edge of the 10%. So I went ahead and changed them. And I went through, and when I got, when I double checked all the resistors to make sure they were at their specific volt resistance levels that are marked on them. They're very close. The 400 precision, the only one I didn't change was the 150, the 150K precision resistor. This one was dead on, so I didn't mess with that one. But the 400 precision, the 400K precision resistor was out of tolerance. There's in the parts manual. That's something else I wanted to mention. This is the schematic for the PS4, and this is the schematic for the IP32, the Heathkit IP32. I cannot tell a difference between the two other than the fuse. The 32 has a 3 amp fuse, and the PS4 has a 1.5 amp fuse. I thought maybe there was a difference in the transformers, is why they had different fuses, but they have the same exact output specification, 100 milliamp, maximum of 125, I believe, at a certain voltage. I remember what that voltage is. So I went online and looked at the IP32 manual. I found it because I couldn't find a PS4 manual because I was having trouble with that high voltage output. So I went online and I wanted as much information as I could about this. And I thought the difference, why the fuses would be a different size, is because of the transformers. But I looked, and they're calling for a 5476 and a 5477. The 5476 is the filament transformer, and the 5477 is the power transformer. So I don't know if it's going to show up here. I'm going to turn this off so I don't get shocked, because I'm stupid enough to put my hand somewhere. I don't know if it's going to show up on camera. It might if I zoom in a bit on that. I know it's upside down, but you can read it. 5476. And see if we can get to the lower one. See if it'll show up on the lower one. If the lower one will show up. 5477. So they're exactly the same transformers. So as far as I can tell, the only difference between the two is that cover decal on the front of the on the front of the front panel. Decal is different between the PS4 and the IP32. The the IP32, from what I've seen online and pictures, some of these lines are in red. These are all white on the PS4. On the IP32, some of these lines are red. Everything appears to be exactly the same, though, otherwise. Weird, right? Why would they do that? I don't know. So, yeah, if you remember where I was having trouble with the high voltage on this machine. Let's turn this back on. I couldn't get it to go above a certain amount, and when I when I solder on these tube sockets, if I'm changing a lot of components, I'll just pull all the tubes out, and I will put them in a bag out of the way after I clean them, or I'll clean them when I pull them out of the bag when I'm done. So I took the tubes out, and before I put them in the bag, I thought, well, let's just run them through the tube tester I have, the Heathkit tube tester I have. And the the 6BH6 tube showed to be bad. 0 on the meter. I couldn't get it to do anything, and I have that other tester, the exact same model, so I drug it out and I plugged it into that, and then it read 0. And I went, I'm going to have to order a tube. And then I remembered, hey, I got a box of old tubes over there. Maybe I got one in there. So I dug that box out, and I dug around, and sure enough, I pulled this tube out of the box. And I plugged it in there. Didn't think anything of it. I took the what I thought was the bad tube, and I threw it over here in my dead parts pile, and I do that until I until I finish the job and make sure everything's working right, and then I'll eventually clean my bench off and toss all those old components away. Regardless of my long story here, is I changed all the components, plugged it in, turned it on, and I couldn't get over 150 volts on the high voltage side. I couldn't for the life of me figure it out, so I started checking voltages. And on the schematic for the PS-4, on the schematic, they give you some voltages. Your transformer voltages, they give you the transformer voltages, and then they give you some output voltages, like, what is that, 230, 270, and then they give you some other voltages, 4 volts here on the plate, and the screens, or grids of the 6L6, and then they have 40 volts written here, 40 volts on your output. And I looked at the instructions down here at the bottom, and it says to have the 0 set pot, which is this one, turned all the way clockwise, and I'm assuming from the top, because there's access holes at the top to turn them, and then to turn the 400 and the high voltage and the C minus, the C minus voltage all the way counterclockwise, and then to take your measurements. Well, I did that, and some of the measurements are there. The 150 negative is there. The 100 and once I changed these resistors on the voltage divider with these 2 pots and these 2 resistors here, there's a voltage divider which is right here. Once I changed those, this come into spec. This negative 152 came into spec, but I still couldn't get over 150 on the output of the high voltage. And I kept checking voltages, and I thought, well, it's got to be that 6BH6. Maybe the Heathkit tester just doesn't test it properly. I know there's a lot of different, that's an emissions tester, I believe, and then there's other tube testers, conductance or whatever they call it. I don't know tube testers that well, but I thought, let's just put the old tube in there to see if there's any difference. I put the old tube in there. Now when I turn, we can watch this. Oh, I gotta put that in DC, sorry. There's 70, 80, 90, 100. So like right in, so I can keep going. I can full voltage here. So we got 400 volts. I'm going to turn it all the way down. Yeah, I don't like that. It must still be cold or something. I'm not sure why that's showing negative 2 volts there. I adjusted that already once. We'll let it run for a little while, warm up all the way. But regardless, that high voltage is working now. So we'll check the filament, the 6.3 filament voltage here, and that's AC. So with no load on it, it's obviously going to be a little higher. Yeah, 6.6, that's normal. We're good there. And before, we never had any problems with the put these two commons are connected together. And we'll go ahead and go here to our C minus. That just switches the meter. The switch here just switches which one's displayed on the meter. So we'll go ahead and turn this up. Now, should that not be a negative voltage? Duh. Turn it back to DC, you moron. I get myself in trouble with these meters if I have to switch. So the maximum on this is supposed to, the panel says 100 volts. So we'll keep turning it up here. I think it'll go as high as, I think, 120 something. Yeah, 100, almost 130. You're not supposed to run it up that high, but it'll go that high. And there's really no adjustment. The resistors inside the machine, I think, are your adjustments for that circuit. And whatever that, whatever the transformer's putting out, and the 6X4 rectifier tube. And with your resistors in that circuit. And the bleed resistors, your bleed resistors, these 27K resistors. There's a string of them here. Voltage dropping resistors that connects the high voltage and the negative voltage together there with some bleeding resistors. So the machine works like it's supposed to. This is working properly now. I have no idea why that tube showed it was bad, but it's working. And I'm not gonna question it. I did order a new tube for it. I got a new 6BH6 coming for it. I don't think there's a problem with it, but I will let it go. So I'm wondering about that. Let's go back to that high voltage and see if we can set the 0. I don't think we're going to get much better than that as far as 0. Let's see if we can turn that max down. Oh, that's as low as it goes. And all those resistors are within tolerance in that voltage dividing circuit. And in the instructions for the IP32 for this adjustment, it said to set it to full, set the 0 pot, and then set the 400, and then reset the 0, and then reset the 400. So it looks like it's, I'm not going to complain. It's not too far over. It's 230 and there's no load on it. And as far as I know, this thing doesn't drop that much voltage when there's a load on it. So I don't think it's going to be a problem. So the next step in this is to, since I don't have the caps, let's turn this off because I will shock myself. I don't have the caps for these binding posts. I went online and I found these, and they accept banana plugs. They're just banana plugs. There's no sticking wires in them. And I thought that's going to be a lot safer, because if we measure the voltage here, we just turned it off. And if we measure the voltage here, DC volts, I should have left this on. I should have paid attention to this. But we still have, like, let's turn this back on here. Let the filament. Something else too is you always want to have this on standby first until the filaments warm up all the way. And once the filaments warm up all the way, you know, 15-20 seconds, then we can turn the power on. And we can crank this up 400 volts. And then if you don't turn that down and we turn this off, we still have like 30 volts there for a few seconds here. You can see it, there's still voltage there. Like close to 50 volts. I'm not saying that's enough you're going to get hurt, but I don't want to be able to have to touch that voltage while it's off. You think once you turn it off you're fine, and I'm wondering about this voltage. Yeah, that one's off. There's nothing there. The 6.3, there's no capacitors in that circuit, but this one, you seen there was voltage there for a few seconds. And then if you did have this sitting on the bench turned on and you're using it, there is a chance these binding post covers of touching this part right here. Of touching, where did my filter go? Of touching this ring right here. There's always a chance of touching these rings from what I've seen of these old binding posts. And I don't want to have a chance of doing that. So I'm going to install these. And they're flat. Let's see if I can get one out here and show you. Well, anyway, once I get these changed, I think I'm going to paint those transformers. They're starting to rust. I'd like to take care of that. If I could just get some rust converting, I don't have any here, but some rust converting chemicals to stop that rust after I sand them off. Maybe I can get some paint that has them. So here's one of the posts I got. There's no way you can get shocked with that. You can't. So my plan is to make, I have the parts to make some test leads for this. Insulated covers. I can make leads that will plug into this here, so I will have an extra set of test leads for meters. And also, right, I can unplug these and plug them into these, but I've got these to do it with. I also have this type here to do it with, which would be these type that stick out, which I'll probably use these to make them. So I'm pretty happy with so far with what I've got. I spent way too much time. I kind of did it to myself on that 6BH, 6BH6. I kind of did that to myself. But, you know, live and learn. That won't happen to me again. I'll make sure. And I've been told that before, the best way to test a tube is in the circuit, not on a tester. So I will not rely on that tester unless I'm having a problem. So the tubes will not end up in the tester unless I'm having a problem with the radio or the piece of equipment I'm working on. Which is why I did it. So I guess kind of shot myself in the foot somehow there. But live and learn. So the next, like I said, change these binding posts out, and then to get some rust converting paint for these transformers. There's a little bit of rust starting to grow on them here. I don't know if I showed you that before or not. You can see it there. You can see the rust growing on them. These cores, I don't know if I'm going to It's this mainly I'm worried about, is the rust on these covers. Yeah, the rust on those covers. Yeah, you can really see it on that one. That one as well. It'll be an easy fix. Alright, we'll be back when there's something more exciting to look at. Well, I got the transformers all prepped up for paint. Got it masked off as best I'm going to get it. I was thinking about pulling the transformers, but I think it'll be okay the way it is. I'll be able to get everything that's rusted. So we'll come back after I get them painted, they're dried and bolted back down. We'll see what it looks like. We'll see you then. Well, I've got the transformers painted and mounted back down. When I was prepping this one for paint, I found the 2 screws were loose on it. So these 2 screws, this one and there's another one around the other side. So I tightened them back up and I sanded them all off, got the rust off of them, got them painted and remounted. So they look pretty good. Not a restoration, preservation. Just trying to preserve this. So these, let's get some rust on them. I don't want them to rust out, and I really don't care what it looks like. It's going to be covered. Nobody's going to see it. So as long as it works right, it works right. It's all good. I also, pardon me, I changed the panel binding posts to banana 4mm banana connectors sockets, so they sit flat. There's no way to electrocute yourself if this thing got left on. Accidentally reach across and you're not going to accidentally shock yourself. So now I need to make some. This is what they look like in here. It's pretty easy. The thing with these are these rings. Do I have any more of these? I don't know what I did with them. The rings aren't nuts. They have, I don't know if you can see that. Yeah, they've got little slots in them. And I was like, how am I going to tighten those down? So I was at the hardware store looking. I took one of these with me to the hardware store and I was looking around and I thought, well, I'm going to have to make a tool. So I found this piece of copper and I thought, yeah, I got to find that. Here they are. Here they are. Let me get one of these out and I'll show you. So you can see the ring on this is not a nut. It's just got 2 little I don't know, slots in them. So I walked around the store and was looking. I couldn't find a tool. I really don't know what to call these. So like I said, I found this, and this fits in here pretty good, and it fits on there nice and tight. Doesn't really move around too much, and it's short and it's bigger around, so you can get some torque on it, right? You can get more torque because it's bigger around. You can get a better purchase on it. And I thought, well, I'd just take my die grinder and modify this, and I marked it. Well, while I was still at the store, I thought, man, it'd be nice if it was plastic, because then I couldn't over torque it and bust the plastic threads. So I found this fitting, and I marked it, and I've cut those little slots with the X-Acto knife. I just shaved. I went straight down next to where I marked it, straight down where I next to mark it, and I just kept carving out next to it. And then I went around, and then, it's not perfect, but it works very well. It works extremely well to tighten these down. And it's at an angle, so you can actually put some torque on it too, right? I wanted to get a 90, but then I didn't have this with me, and I didn't know if the 90 would be too far and interfere with any of the components, so you'd have to go, just a little bit at a time. But this works perfect. This works so good on these. So if you ever run into that, you can just make your own tool with an X-Acto knife and a piece of this plastic fitting. I think this is 3/8 by half in this crappy PAX. Yeah, half. I think yeah, 3/8 by half. 45. I think it was like 38 cents. Wasn't very much at all. It's pretty cheap. So I got those in there. So I thought I'm gonna have to make leads. So I got some of these type of banana connectors that you can stack. They're stackable, and I'll have to make my own leads. And on the other end, I got regular test lead ends. So you keep thinking, what are you going to use to connect it with? I got these. So you got different colored ones, so you can know filament voltages, your B minus, your C minus, and your B positive, right? And your grounds. I only got 2 for grounds, but hey, it is what it is. And the other thing too is I can use my hooks if I need to, if there's a tight spot where I can't get in there. Since they're alligator, all of my test leads will work, so I can use these as well because they'll fit right on them. Nice and safe. So I'll get some test leads made up, and the new tube will be here tomorrow. Pardon me. And I also made a new cord. I made a new electrical cord for it. A new electrical cord, polarized, and I went ahead and kept it the way it was. The neutral goes up to the switch, and the line comes to the fuse. And I thought it'd be better that way, because if anything shorted out, then we cut the power out and it won't electrify the case, because it's all metal. And this is all separated, so the case is not connected to ground on this. There's a spot here on the front panel where you can see the wire coming from. Yes, this one I replaced these wires because the ones that were in here were short. This goes to the case from the front, and on the front they show you connecting these two together, and I really don't see a reason to do that. I don't want this to be electrified in any way, especially when I'm running on the Variac and the isolation transformer. I don't want any connection to ground in between, so nothing can get electrified, so I'll be safe. This is turning out to be pretty good so far. I'm pretty happy with it, the way it looks. Yeah, just make some leads for it, and when that tube shows up, I'll put it in there. Yeah, so if anything else exciting comes along after I get the leads made, I'll show you. I might because these are a little bit confusing on how to build. I might go over that with you when I go to do that. I appreciate you guys hanging out and watching, and if you're having trouble with your PS4, you got the IP32 looks exactly the same. Like I said, the only difference is the fuse that I could find, and the front panel. The decal on the front panel, or whatever, the painting on the front panel is a little bit different. So, alright, thanks for watching. I'll get back to you when we can. Okay, I've got the PS4 back together. I changed all of the control tubes. The AO, I think they're AO. No, I can't remember now. Why am I having a brain fart on this? Oh, come on. You know better than this. They're AO2s. They're 0A2s. I changed those in the 6BH6. So all of the regulator tubes have been changed in this power supply. I wanted to test it, and I thought about how to test it, and I've got... Oh, why are you doing that? Keep moving on me there. Come on. So I've got a 25 watt 1200 ohm resistor here on the high power side, so we'll make sure the amp meter works like it should. I've got a 6D6 on the 6.3 filament, and I know these tubes, the big pins are the filaments, so I've got that hooked up to there. And then I've got it piggybacked with my voltmeter so we can monitor that voltage. So we'll flip that on. I should have set this up so you can see both. Okay, that's a little better. So you can read the amperage on the, pardon me, on the you can read the amperage on the dim bulb isolation transformer. So we'll go ahead and flip this into standby. So when you put it on standby, it powers up the transformer for the filaments. So right now it's warming all the tubes, plus it makes this hot. This 6.3 is ready to roll here. So this tube should be making some, should be starting to glow here in a second. Let's see if we can see it without the, I may have to turn the light off. So you can see it glowing in there. So we'll leave that hooked up. So 0.2 with this filament, this extra filament on there is what it's drawing, 0.2 amps. So we'll go ahead and flip this on. We'll see the inrush, 0.52. It should be coming down. 0.45. So go ahead and turn this up a little bit. We'll watch this amp meter over here. Oh, got that on the wrong voltage. So right there is right around 50 volts. And we're just short of 30 milliamps. So the meter's working. We'll just watch the amps. It's the amps. So 75 amps or milliamps. We're just short of 95 or 90. Just short of 90 volts. So we'll take her on up to 100 here. Keep her in the... There's 100 volts on that meter. And we'll let her run here for a few seconds. Our voltage for our filaments are still good, so looks like everything's working. See how warm this is getting. It's just warm, not getting hot. So that's working like it should. Let's move the meter. Let's flip this over. And we will move the meter. I'm getting a jumble of wires here. I'm not liking it. But that's just the way it is right now. Okay. So now we're going to monitor the C- voltage, our bias voltage. So it should be coming up on this here and here because I've moved the meter switch over. Yep. So we're on the bottom scale. So there's about 50 and 50 on the meter, so that's pretty close. So that's about 75 on the meter and 75 here. Now it says 100 volt max for this. So 99, it's close enough. I think this will go as high as I think right around 100 and just short of 130 with no load on it. So I'm gonna say success. It's working like it should. Pretty happy with it. I want to thank you for watching, and oh, I didn't know if I mentioned it, but I took those, I forgot, I took the selenium rectifiers out of this. I took the seleniums out. The selenium rectifiers, I took them out and I replaced them, put a terminal strip in there, and I replaced them with these, the NTE 580s. They're 3 amp, so they're going to be more than enough to do what it needs to do, and it seems to be working fine. So, pretty happy with the operation of this. Like I said, the only difference between this and the IP32 that I could tell is the front face decal and that fuse. This should have came with a 1.5 amp fuse, and the IP32 has a 3 amp fuse, but everything else is exactly the same. The output, everything is exactly the same. So I went ahead and put a 3 amp fuse in this. Not that I need it, and it never went over an amp. Never went over just a little bit over an amp on that when we were, you know, just close to about an amp when we were cranking that up. So it's all good to go. Right, I got new rubber feet on the power supply. Got them on Amazon. It's a pretty good price, cheap enough. They're 1/4 inch. They fit 1/4 inch holes. They're just push in, so they work pretty good. I'm surprised at how well they work. I mean, once it's on the bench here, you got to lift it up to move it. And before, you know, with the old feet, the 2 that were on it and the 2 that were missing, you had to hold on to it to plug them in. Now you can just push them in. It doesn't slide. They work pretty good. I like how well those feet grip. That's pretty nice. It doesn't slide around on the bench. So that pretty much does it for this power supply. She's ready to roll, so I can start working on some of those battery powered radios I have. Hopefully this can do the work that's needed. Pardon me. That I think it'll be good enough, because I don't think any of those draw more than an amp as far as battery wise. Otherwise the batteries would go dead pretty freaking quick. Alright, well, thanks for watching. Leave a comment down below.